We want to find the equation or an equation of the plane that passes through these 3 points. Negative 4, 1, 3, 5, negative 1, negative 3, and 2, 2, negative 6. So here's the thing. If you have a plane, so we're doing part C. If you have a plane, which I can try and picture like this. So imagine this plane is coming out of the screen. And imagine there's 3 points contained within it. So point P, point Q, and point R. So we'll just say for the sake of argument, this is P, this is Q, this point's Q, and this point's R. To get the equation of a plane, first of all, 3 points should determine a plane, right? In fact, that's why tripods are made the way they are, to have 3 legs, because the tips of the legs are 3 points which lie in one single plane. So as long as the ground is fairly level, or really it doesn't even matter unless it's massively unlevel, you can count on your tripod holding steady. Whereas if you had 4 legs, 4 points don't necessarily lie in a plane. So like on a regular table, it might tilt if they're not all exactly the same length or the ground's a little bit off. Okay, so we should be able to find the equation of a plane containing any 3 points. So according to that equation of the plane that I came up with in the lecture for this section, what 2 things do you need to find the equation of a plane? So whether you're looking at A, B, C, or D, you need to think, based on the given information, I need to find a normal vector to the plane. And what else? So you need, to find the equation of a plane, you need a normal vector. That's one thing you need. And you need a point on the plane. If you have those 2 things, you've got yourself the equation of a plane if you just fill it in, and I'll show you how to do that in a second. So how do we get a normal vector is what this breaks down to. Well, what operation is really good at finding normal vectors? The cross product, which we talked about in 12.5. So let me draw in a couple of vectors. So the vector PQ, we've got to find that. And well, this is one way to do it anyway. And the vector PR. If we cross vectors PQ and PR, then guess what? We'll end up with a vector that's perpendicular to both. That's the whole point of the cross product. So this will form a right angle. This vector, this normal vector we can call it, will form, which is going to be PQ cross PR. And it could point the other way as well, right? In fact, if I'm not careful, I could have drawn it wrong. No, because PQ is on the right. PQ is the right hand. PR is the left hand. So the normal vector will point, the way I have drawn it, upwards. It forms a right-hand system. So you can be guaranteed that this vector PQ cross PR, which we'll call N, is perpendicular to both PR and PQ. So all we have to do is find those 2 vectors and then take the cross product. And that's if there is a hard part, that's it. So what would vector PQ be in, well, you got to do it in component form. So what would PQ look like in component form? So yeah, okay. So that would be 5 minus negative 4, 9, sure. Negative 1 minus negative 1, negative 2, sure. And negative 6. Everybody see how he got that? Okay, and then PR. So take a look at P as your initial point and R as your terminal point. R as the tail, P as... or R is the tip rather, and P is the tail. So what is that in component form? 2 minus negative 4, 6. 2 minus 1 is 1. Negative 6 minus 3 is negative 9. Does everybody see what I'm doing to get those? tip minus the tail component-wise, right? Let's go ahead and find PQ cross PR. Okay, so we create this kind of pseudo determinant rather, or a pseudo matrix to start with, and then it's a pseudo determinant because in the top row we put vectors, and in a real determinant you never have vectors, I, j, and k. Then what do we put in the second row? The components of, let's say, PQ. So 9, -2, -6. And then 6, 1, -9. Let's go ahead and apply the cross product. So you think, okay, I'm going to take the determinant, cross out first row, first column, take the 2 by 2 determinant, -2, -6, 1, -9, take the determinant of that submatrix, and that's going to be your I component, right? So I don't want those lines there really. So what's that going to be? What's the determinant of this matrix? -2, -6, 1, -9. What would that be? It would be, so 18, right? That guy times that guy, minus that guy times that guy. So what would that be? Minus -6 would be +6. So I'm going to go ahead and show that much work. If you want to go right to 24, you could do that, but if you don't show that work and you make a mistake with the negative, I can't give you as much partial credit as I could if you show the work, right? Like on a test. Okay, so I'll make that 24 in the next step. And then remember, by definition, what's the next sign? Minus. And then cross out that column and take the determinant of 9, -6, 6, -9. And so what do you get if you do that? So negative, well, okay, but if we do that, we get, I see, you're just giving it to me in parts. Okay, good. So -81 and then what? -81 and then minus a -36, so +36. And then that'll be J, right? Everybody agree with that? Okay, and then for K, let me get rid of this extra stuff. For K, cross out last column, always the first row. Take the determinant of 9, -2, 6, 1. It'll be plus there, and what do you get? So 9. Yeah, minus, at least on one of these I'm going to put it in because you'll start to think that the definition has a plus in it if I don't. It's this guy, 9, this product, 9 times 1 minus this product, right? Except it should have been a 12, I guess. Does everybody believe that? Okay. And again, if you just want to write that as 9 plus 12, that's fine. So you said 24i. What is it? What's -81 plus 36? 45. And then with, it's minus 45, then with minus in front plus 45. Does everybody believe that? 45J. Okay, and then what do we get here? 9 plus 12. 21K. Okay. Now, is there a way you can check your answer? If you take the dot product with PQ and separately the dot product with PR, what should you get both times? 0. You can do that if you want. I'm not going to do it. So I've got this guy. Now, do I have to use this vector? Can I use any multiple of it? See, the idea is, I called that vector n earlier, but I could use any multiple of it and call that n instead, because it will still be parallel, right? In fact, I'm thinking of using 1/3 of that, because I see that 3 goes into all of those components, right? So I'm going to divide, well, let's say multiply by 1/3. So multiply by 1/3, and I'm going to call my normal vector n. What would I get? 8i to start with, plus 15, plus 7. Does everybody see why I did that? Just to make life a little bit easier, right? Now, if you didn't do that, it wouldn't make a difference because when you create the equation, those components become the coefficients of x, y, and z. And you could just divide through by 3 at that point once you create your equation, and it will be an equivalent equation. Okay, so we've got our normal vector, and we've got 3 points. I said we need a normal vector, got it, and a point on the plane. Well, we're given 3 points, right? So does it matter which one we use here? No. Really doesn't. I'm going to use 2, 2, negative 6, just for the heck of it. So I'm going to use the point 2, 2, negative 6, and you just have to make sure you copy it down right. Okay, so remember what the standard form of the equation of the plane is. You're going to take let me write this formula down separately just to remind you. If n has components, I probably used a, b, c in the video. That's the standard form of the equation of your plane. And you just fill in a, b, and c, and then x naught, y naught, and z naught, right, would be the coordinates of the point on the plane. So fill it in then for this. What do you get? So your A, your B, and your C, and then your X naught, your Y naught, and your Z naught. So fill in A. What's A? 8 times X minus 2. There you go. Plus B, 15 times Y minus 2. Plus C, 7 times Z minus negative 6, so Z plus 6 equals 0. 8x minus 16, multiply it out, plus 15y minus 30, plus 7z plus 42 equals 0. So 8x plus, I'm grouping the 8x plus the 15y plus the 7z together. So I took care of that guy, and that guy. And then if you go minus 16 minus 30, you get minus 46. Plus 42 is minus 4, but you add it to the other side, and you get plus 4. And so that's where the answer comes from in the answer key.